Cheers. Cheers. No, he's not. Oh! Yay! Nah, sorry.
Wait.
Are you ready? Okay. Running? Perfect. Yeah. So, unfortunately, I didn't get permission yet to do this talk. So, I hope to see you at Recon to do it. I'm not sure it will be possible, but I try to submit it and get authorization. So, I used to work for the French Cyber Defense Agency, so maybe I could tell you about Babar, but I'm not going to. Or about the goal, but I'm not going to. So instead, I'm going to speak about reverse engineering frameworks. Not talking about these assemblers, because you just use Capstone. So basically, this is a shameless vendor pitch for tools that were developed by friends. So they're not here to talk about their tools, so I'm doing that for them. Actually, I'm going to talk about a tool we developed also. So 3 reverse engineering frameworks. You may know some of them, probably not all of them. So Metasp, Amoco, and Miasm2. And at a bonus, we'll have Rebus. So they both all have some cool features like basic disassembler, assembler, LFP parsers. They're all written in script languages, they're all open source, and they all handle memory mapping and virtual addresses and all the stuff you can expect in our RE framework. So first, you have, oh, sorry, there's a typo, it's Metasp. So Metasp by Johan Guillot, also known as JJ. It's the oldest of the 3. It's been developed for more than almost 10 years, I guess. It's coded in Ruby. It's very awesome because it has shitloads of CPU supported. So you get like classic ones, but you also have PIC, SH4, some Dalvik. You have quite a lot of things, so you can have fun with it. It's also able to do semantics for instructions that you can use for slicing or backtracking. It has a debugger, a decompiler, like a kind of a decompiler. But if you want to decompile, for example, 16-bit code, it's the only one I know that's able to do that. It also has a GUI with graphs and everything. So it's cool stuff, but unfortunately, well, it's Ruby, so it's a bit slow. And it's unmaintained and a bit complex to dig in. So there is another framework. It's really cool. It's Amoco. It's developed by my boss, so I have to do this pitch. Axel. This one is developed in Python. It supports 886, ARM, MSP, Z80, PIC, Spark. The cool thing with Amoco is it's very, very easy to add new instructions or architectures. It took me like 2 hours to add 886 FPU instructions decoding and encoding, so that's pretty cool. It also has semantics supports. It's integrated with Z3, which was just released under MIT license by Microsoft. I think some people at Microsoft are getting high on crack. They are releasing such many things under open source licensing. You don't know what's going on out there. So it works with Z3, so it's pretty cool because you can use it for disassembly, so it can follow jump using Z3 to resolve potential targets. And the API is very simple, so it's pretty easy to use. Unfortunately, it's not used widely, so I hope this talk will make you use it. And so since it's not used widely, you usually find bugs when you start using it. So now the coolest of the 3, I think, Miasm2, which is developed by Serpillière, you may know it, for all previous research. So it's done in Python too. It supports classical CPUs. And it's very awesome because it has, besides semantics and symbolic execution, it supports a JIT. So it supports several JIT engines, and you can disassemble code and recompile it with TinyCC, for example, for execution. So it's fucking awesome. And for example, they have several samples where they do Win32 emulation in Python. So you can have static unbackers. So you have a PE loader, symbolic execution, and also some API simulation in Python. So you can make really simple static unpackers. It's also possible to interface it with IDA. I'll show you later. And what's very cool is that there is quite a few regression tests. So basically, it works, and there are quite a few bugs that they were catched with regression testing. And they are very, very active in development. So, ah shit, I get to drink.
Yes, you get a drink.
Perfect.
No.
Oh, this one. Sorry. Okay. 5 minutes more.
Yes.
Cheers.
Yes.
Okay, I'm almost done. Perfect. So, for example, they have a plugin for IDA, which is used for register slicing. So you basically right-click in your function, and you say, I want to track the location. Well, where is EAX modified before this location? You click launch. It just does a symbolic analysis of the function, and then it colors the graph, and it says, for example, if you look for EAX here, it's modified and set up here. So you can definitely find it very easily where your data is modified and where your register is modified. So it's awesome. And they use also Miasm for Sybil, which is a function divination tool, which works for several architecture. It's, for example, you load a binary for a proprietary operating system, for example. You pass it through Sybil, and it will try to emulate every function using symbolic execution and try to identify the semantics of the function. So for example, you have divination possibilities for strlen, memcopy, memmove, etc. It's fucking awesome. It's a bit slow, but it's awesome. Oh, and by the way, our team is developing a reverse engineering bus. So I'm not going to go into the details because it's a bit complicated to explain. However, my colleagues are going to present it at STIC, which is a French conference, which is awesome. And there is going to be a research paper explaining everything that's going to be in English. So it's going to be published in June. The code is already out there, but you can try it. So thanks a lot.
Thank you.